I request you to grab a piece of paper and a pen and if possible a calculator. So we'll all do together. So I assume that most of you will fetch the required items by during this particular point. So I'll just proceed problems. And this is payoff matrix for player A, and payoff matrix for player B. This is A1 and A2. This is row A1 and A2. This is column B1 and B2, right? So this is typically an example of a game which doesn't have a saddle point. And for the initial stage, we'll be finding the row minimum for the first row. In this case, 5 and 2. The minimum of 5 and 2 is 2. We'll go back to the next row. We'll find the minimum of 3 or 4, and the minimum is 3. All right. And the row minimum will be like the minimum of the rows, and next one will be maximum of these two rows. Like it's called maximum of the row minimums. Maximum of 2 and 3 is 3. And we'll come back to the column. In column, we'll take the maximum. Remember that in the row, we'll take minimum and find out the maximum of minimum. In the column, we'll find the maximum and we'll find minimum of the maximum. It's called min max. And in this case is 5 and 3, and the greater number is 5, so we'll put 5 here. And out of 2 and 4, the greater is 4, and we'll incorporate 4 here. And this is the column maximum. Then we'll find minimum of the maximum. In 5 and 4, the minimum is 4. So this is the minimum of the maximum. So in this case, maximin is not equals to minimax, and which means there is no saddle point exists. And this game is a typically game that doesn't have a saddle point, or it's a mixed strategy, something called no unique strategy, but we need to derive the mixed strategy. So we'll be finding out the strategy of A, which is P1 and P2. When we find the P1, we can find P2, which is nothing but the probability of what we call the payoff A1. P1, P2 is 1 minus P1. So which means that the sum of the what do you call the probability is equals to 1. So P1 corresponds to the payoff of A1 and P2 corresponds to the payoff of A2. And similarly, we have got strategy B. Since it's a two-player game, so we'll have got player A and player B, strategy for A and strategy for player B. And B1 stands for the B1 payoff, and Q1 is the probability of B1, and Q2 is the probability of B2. So this is a typical thing. I request you to note down the formula quickly as possible. And this is P1. The formula is this: A22 minus A21. So before that, just take note of this notation: player A and player B. A11 is the first cell, first uh, payoff of A1 and first payoff of B1. So that's what is represented as A11. And it's just like think of a matrix. So this is a cell A11, and this is first row, first column, and first row, second column, and second row, first column, and second row, second column. So this is a very important thing. So kindly make a note of this. All right, so hope you have time to note down this, and next we'll dive into the formula. This is the formula. Take it down quickly as possible. This is the probability of 1, which is the A1, and this represents probability of what do you call the first strategy of player B. So once you find P1, you can find P2 by 1 minus P1, since the sum of probability P1 plus P2 equals 1. So this is a typical probability calculation. Probability of favorable and probability of unfavorable. Probably if you understand those concepts, like probability of favorable will be some percentage, and unfavorable will be the 1 minus of that favorable percentage. If you have taken down, just kindly let me know. And once you have taken down this formula, this is the value of the game. So V stands for value of the game. So I'll just come back to that a little later. But take down the probability formula. If you worked in Excel, then probably incorporating this formula may not be a very difficult task. So you'll get the answers very quickly if you inbuild the formula.
Got it, sir.
Okay, then. Very good. Then we'll take the can you take down the formula for the value of the game?
Yes, sir.
Okay, then. So very good. So in this case, uh, we found out using the formula. In fact, this we have done in the previous class as well, but uh, to give you a flavor, and I've just represented it again. So A11 is 0.25, which is 1 by 4th, and this is 3 by 4. So A2 is a predominant what do you call strategy for player A, and in for player B, B1 and B2, either anything the player B chooses will have the equivalent or the equal chances of 0.5, 1 by 2. And the value of the game is 3 by 5. That's just pretty much. So it's not 3, it is not 4. The value is 3 by 3 and a half. So that is typically the value of the game. So I hope you have done this. Let's use computer to solve this. So I'm gonna go to game theory, and let me, yeah. All of you could able to see the screen. The name of this software is called Tora. It's an operation research software. I'm gonna click main menu. All of you could see the screen.
Yes, sir.
Okay. So I'm gonna go to zero sum games, and I'm gonna go to input, and I'm gonna click solve. I don't want to save at this point of time. Software is going out, so it's popping out, so that's why I have to do it. All of you could able to see this. It
Yes, sir.
gave the answer exactly the same. The value of the game is 3.50, and the probability of the player A1, which is P1, which is 0.25, and probability of A2, which is P2, which is 1 minus P1, which is 0.75, and B1 and B2 is 0.50 respectively. So this is how you can use computers to derive the what do you call the chances or the playoff or the value of the game, something like that. All right. So this is a typically non-saddle point game, but manual computation of 3 by 3 or 4 by 4 or 5 by 5, and the order n increases will also increase the complexity of the computation or the manual computation. Then we'll be focusing and we'll be focusing primarily on the dominance property, which is that we'll reduce the larger games into 2 by 2. So anything that is more than 2 by 2 matrix will converge into a 2 by 2 and we'll solve it. So how do we converge into a 2 by 2 is, many ask me or raise me a question um, after the class, I mean after the previous class, and I'm just gonna tell you that you will be eliminating where you feel the row if for example we'll first eliminate one row, then we'll eliminate one column. So in this case it's 3 by 3. You can eliminate any row, but if you eliminate a row that contains a huge number, then which means you are avoiding that particular route, and which means that when you don't take that route, and if you fail, you will not be penalized to a greater extent. So that's a basic idea. So in this case, you can even take row 2 because it has got 6 and 7. But I believe I've taken maybe we'll try computer, say what computer gives us the answer. So that's also we can try doing it. And so first I eliminate the row 3, that will leave us row 1 and row 2. And then I eliminate 7 here. You can even do the 7 too. This is fairly the same. So I eliminate this column, and finally it converges into this 2 by 2 matrix. So the A11 is 1, A12 is 7, A21 is 6, A22 is 2. So this is what I finally get from this particular thing. And let's take a look at whether this is 1, 2, 6, 7. All right. So let's do that in a computer. All right. I'll go to Dora, 0, 7. So in this case, I've got 2. In this case, it's 1, 2, 6, 7, and I'll solve this. Yeah, here it is. Here also probability of B1 and B2 is zero point 0.5 and zero point 0.5. I'll just show you the solution. Yeah. Here also the probability is uh, computed quickly, and the P1 value is zero point 0.4 and not in favor of A2. So A2 is a good strategy to take because it has got a probability of zero point 0.6. And for B1 and B2, it's fairly the same because zero point 0.5 and zero point 0.5, and doesn't make any difference for player B. So this is the iteration we got based on the my what do you call trial and error, or the process which I've taken or considered, or the rows which I have eliminated and columns which I have eliminated. And the value of the game is 4. So let's dive in and we'll do probably the other, we'll try eliminating the other and see whether the value of the game increases and the strategy changes, right? I'll go back to the original stuff. So I'll go back to this document. Instead of eliminating row 3, in this case, I eliminate row 2. So that leaves me with 1, 7, 2 and 5, 1, 6. Then I'll just eliminate the column 2 because that has a 7. So which means that I have got 1, 2, 5 and 6. Let's dive in. I repeat, I have got 1, 2, 5, 6. I'll go to Torah. I'll go to main menu. I'll create zero sum game. It is 2, and it is 1, and so I'm gonna solve. No. Here is the solution for the other type or other what do you call, if you remove the other rows and columns, and so the value of the game is fairly greater when compared to the previous one. It is 5, and A1 is 0, and B1, I mean the P1, and what do you call, the Q1 is 0, and Q2 and P2 is favorable. The reason is that I'll just show you. It is 1, and in this case, in the row which is considered to be B2 is predominant, and in this particular 2 is predominant, and for B2, he has to choose the least one because 5 is lesser than 6, so which means this is predominant. So that is how it is. Like if a player for victory, player A has to choose this 2. For what do you call, for B, player B, to avoid catastrophic defeat, then he or she has to do Q2. So it's fairly the same. So this is how you do different trials and error, and finally you will be selecting out. The possibilities are still there because we can even still do with different 2 by 2 matrix from this, and probably that's how you finally find out based on the value of the game. So the value of the game determines the best strategy. So this is something and a trial and error. So you should really understand this, so that you can probably apply this strategy in a real case also. All right. So I request you to take up this problem, and with that we'll wind the class. So all of you kindly take
Sir,
a,
one doubt, sir.
yeah, yeah, go ahead.
So which value should we take, like for the rows and column, which we get the maximum value for the game, or what?
You
Like
mean,
there is also one case left, like for if we eliminate row one
yeah,
and column one.
correct. But in that case, like you see, most of the numbers are bigger, little bigger. So generally, it's not reversible. But I advise you to take a look at this problem also, solve using the formula, and find what is the value of the game. All right. Since you have asked, we can try that also. It is 2716, correct? So I'm gonna
Yes, sir.
just, all right. So um, I'll share the screen. 2716, I guess. Yeah. So it is 2716. Probably we can solve this. Yeah. Can you able to see this? It favors A1. I mean Q1, P1 and Q1, whereas the other strategy becomes 0, so because 1 minus 1 is 0. So but the value of the game is 2, so it is not a very good strategy if you do that way. So it's all trial and error, but only the value of the game that decides the best strategy. So when I compare to the first case, first iteration, we have got the value of the game to be 4, and in the next iteration we have got the value of the game to be 5, and in the third iteration we have got the value of the game to be 2. So if you what do you call, if you take a look into all the three different things, then you probably would advise the iteration 2. So not the first case and not the one which you have done last. Okay. And you can formulate the game theory concepts using linear programming also. That is kind of a different thing, which is not a part of this course, but you can always learn linear programming in your operations research class, and you can solve using computers, or even you can use Excel to do this. All right. So this is typically a software. that gives us fairly a quicker value. You can even incorporate this formulas in Excel, and you can even derive automated stuff, right? So that is how you make different iteration, and you find when the matrix gets increased in dimension, the number of iteration goes very high. So the 2 by 2 matrix, you can have multiple, you can derive many 2 by 2 matrix from a single n by n matrix. So that is the basic logic, right? So I'm going to exit the software.